Algebra 2, Concept 7C. We're going to continue graphing quadratic functions. Now we're going to look at the functions in intercept form. A better way to think of this is in x-intercept form. So here is the general form for this quadratic equation. It is f of x or y equals a times the quantity x minus p times the quantity x minus q. So the values a, p, and q are constants, are numbers. P and q are the x-intercepts. They're the points where the parabola crosses the x-axis. So you can put them in coordinate form. So p comma 0 would be one point you can graph, and q comma 0 is a second point that you can graph. X-intercepts are the point or points where the parabola intersects or crosses the x-axis. Now also to your notes, go ahead and add, to find the vertex, the x value of the vertex, you're going to find the center of those two intercepts. So you'll take p plus q and divide it by 2. To find the y value of the vertex, you're going to plug in the value that you found for x to find y. Now these definitions are the same as from concept 7b and 7a. So if you want, you can pause the video and get those notes down again for the max and min, the domain, and the range. But let's get to graphing in x-intercept form. So just like the other two forms, I've given you step by step. The first thing you want to always do is look at the equation and anticipate any transformations from that parent function. So the one value you're going to want to look at is the a value, because from the a value, if it's positive, you know that the parabola will open up. If it's negative, it's going to be reflected, so it will open down. If it's greater than 1, you'll have a stretch, and if it's less than 1, you'll have a vertical shrink. All right, then you're going to start by finding the x-intercepts. You're simply going to pick out p and q. So you'll find out what p equals, and you'll find out what q equals. And then you'll write those as ordered pairs. So p comma 0, that would be your first point that you can graph, and q 0 would be the second point. Now you want to find the axis of symmetry. So you'll find the middle of those two intercepts. You'll take p plus q and divide it by 2. That is also the x value of the vertex. And then to find the y value, you're going to plug in that value for x. Then you'll have 3 points, and with these quadratics, we just use 3 points to graph them if the parabola crosses in 2 places. All right, let's go ahead and use these steps to graph. So our first example, we'll move on to example 1, there we go, is f of x equals negative 2 times x minus 1 times x plus 3. So this is an intercept form. Notice you have 2 sets of parentheses. You won't always have that, but you'll have one x times another. Your a value is negative 2. So we can anticipate that when we graph this, it's going to be an x-axis reflection and a vertical stretch. So our p value is what's being subtracted, which is positive 1. And then if you have x plus 3, that means a negative 3 is being subtracted. You can also think of it as that p and q are just the opposite signs of what you see in the equation. So our two x-intercept points are the point 1, 0 and negative 3, 0. Now to find the x value of the vertex, we're going to add p and q and divide by 2. So negative 2 divided by 2 will give you negative 1. And then we'll plug in -1 to our equation. So plug in -1. Now you can type this into your calculator just as you see it and then press enter. Or you can just do the math in your head. You should get +8. So now our vertex as an ordered pair is -1, 8. Our axis of symmetry is going to be the x value of the vertex, which is -1. Alright, now we're ready to graph, and we have our 3 points. So in this form, we'll only use 3 points because we have 3 great points. So there's our first intercept, then we've got our vertex, and then our second intercept. Alright, be sure and draw and label your x and your y axis, and then label a scale. You'll need to do this to get full credit when you're doing your unit exam. I'm going to graph in red. So I've got the point 1, 0, -1, 8, and then -3, 0. So it's a nice, smooth U-shaped curve. Try not to make it pointed. And then we'll put a dashed line through the axis of symmetry, which is right where x equals -1. And then let's identify domain and range. Domain of quadratics is always all real numbers. And then our range, notice that the graph opens down. So our y values are going to be less than or equal to the y value of the vertex. So y is less than or equal to 8. Alright, now we have graphed it, and I believe we have answered all the questions. Let's try another, no, minimum or maximum. So notice that the graph is opening down, so the vertex is the highest point. So in this case, it is a maximum. Alright, now let's graph example 2. So our a value is 1/4. That will be a vertical shrink. So this graph is going to be wider than the parent function. Let's start by picking out P and Q. So it's +6 and +2. So that means our two x-intercept points are at 6, 0 and 2, 0. Now to find the x value of the vertex, we'll take 6 plus 2, divide it by 2, and that'll give us 4. And then we'll plug in 4 to find the y value. So 1/4 times 4 minus 6 times 4 minus 2. Now remember, when you plug this in your calculator, you can enter 1/4 as using your fraction key, or you can just, in a parentheses, enter it as 1 divided by 4. And then after you do that and press enter, you should get -1. So our vertex is at 4, -1. Angle of symmetry is, remember, the x value of the vertex. So it is at x equals 4. Alright, so we can just fill in our table now. We work for it. So we have a point 6, 0, and then our vertex at 4, -1, and our other x-intercept at 2, 0. So draw your xy axis. Let's see if it'll let me. There we go. Label a scale. So 0.60, 4, -1, and 2, 0. So this parabola is, you can see, wider than our parent function. The domain is always all real numbers. And then our range, since it opens up, will be y is greater than or equal to, and the y value of the vertex, -1. And since it is opening up, this is a minimum. So now we're to the independent practice. Pause the video and graph the problems in the independent practice, and then come back and check your work. All right, take a moment and check your answer on number 1. Look and see if our values and our table of values match along with the domain and range. And make sure that you have all the elements of the graph. So, especially with 3 points, you still need to draw a nice smooth U-shaped curve. Just don't make sure it gets pointy. And then sketch in that axis of symmetry. Now I'm going to talk you through this problem because this is an important problem. Because this equation, even though it doesn't look like it is in intercept form, it actually is. So what we can do is that we can insert a parentheses around this x. So we'll leave the negative sign out front. So technically this is just x minus nothing, minus 0, times x minus 6. So right here, we're just rewriting that as x minus 0. So now you can see it is in intercept form, and we have a really clear p value, which is 0, and a q value, which is 6. So our two x-intercepts are the points 0, 0, and 6, 0. So now we can find the vertex by taking p plus q and divided by 2. And then plugging in that x value into our equation. So we can put it into the original form, -3 times 3 minus 6. You can plug that straight into your calculator and press enter, and you should get positive 9. And so our vertex is the point 3, 9. And now we have our 3 points that we can graph. So our point 0, 0, our vertex 3, 9, and then our other intercept at 6, 0. Be sure to draw your XY axis. Label a scale. And then graph your points. And again, just make sure that you make a nice smooth U-shaped curve. And then let's sketch in that axis of symmetry. So that is that invisible line of symmetry that goes right through the x value of the vertex. And let's go ahead and write in the equation of that. So our axis of symmetry is x equals positive 3. Now, I know what you're thinking. You know the domain. It's all real numbers. And then the range. So look how the graph opens. See how it opens down? So that means our range will be y values that are less than or equal to the y value of the vertex. So less than or equal to 9. And then that is a maximum since it's opening down. Now again, just make sure that you remember this because this will come up again on your study guide and possibly your unit exam.